The basics of compression and limiting. I'm going to explain how to use a compressor and what are all the functions. The first thing you need to know is that there is so much misleading and often false information out there. There's also a lot of conflicting information out there. I'm not going to explain all the functions or theoretical information about compressors. Please see Professor Abbott for a complete, thorough, and technical explanation on compression. He's amazing. What I will be teaching you is the creative applications of compressors. We will learn the how, why, and when to use a compressor, particularly in the creation of music. So this video will be about the practical applications of a compressor. So what is a compressor? A compressor is designed primarily to limit dynamic range. Now, what is dynamic range? Dynamic range is the difference between the loudest and the softest sounds. For much of this tutorial, we'll be using a volume graph to show the volume of music or sound over time. This is not to be confused with a waveform graph where we're actually seeing the waveform at the time. So do not confuse this with what an audio signal might look like in a DAW. These are going to be volume graphs, typically measuring decibels from 0 dB to anywhere from 100 dB or more or less. A compressor is designed to limit the dynamic range. Typically, this means that the highest volume sections or sounds come down a little bit, thus are more controlled, and the end result is that the low volume sounds will sound raised up in volume. This will mean that the music will still have louder and softer moments, but is much closer together between the loudest and the softest sounds. An example of when we might use compression is when we're working with our vocalist and they might be singing really loud above the music, almost drowning out the music in sections, and that there might be other parts where the singer is singing so soft that you can barely hear the vocals over the music. Many recording engineers use compression on all the vocals of a mix. There are, of course, other typical uses of compression, as well as some cool artistic uses of compression. We can use compression on drums, on strings, on brass, on just about everything. There are also people who will never use a compressor on anything. If we don't use a compressor, we might have to use a lot of volume automation on a vocal part or any sound we want to reduce or increase in the mix to find the right balance in our mix. Of course, many recording engineers and sound artists use volume automation in tandem with compression. So I might compress a track and then fine-tune with automation. Let's go over some of the basic controls and functions on a compressor. One of the controls on a compressor is something called threshold. With the threshold, we're telling the compressor when to react to a sound. So if I have a threshold that's set very high in terms of dB, the compressor won't react to anything. So if nothing is crossing the threshold, the compressor doesn't compress. If I bring down the threshold a little bit, we might just compress a moment or two. So there's only just a tiny bit of compression. And if we bring the compressor down even more, the compressor will be working to bring down the loud sections and it'll leave the soft sections alone. Ratio is another control that we'll have on a compressor. And so on compressors, we might see ratios like 2:1 or 4:1 or 10:1. And what this means is that for every decibel of volume above the threshold, part of the sound will be reduced by the ratio. So, for instance, if our peak is 10 dB above the threshold, and my ratio is set to 2 to 1. Then the compressor reduces the level to 5 dB above the threshold. In other words, it reduces it by 5 dB. A lower ratio typically has a smoothing effect. The compressor does not do too much work. A higher ratio will mean that the compressor is working very hard, and anything above the threshold will be pulled down harder and harder. Any ratios above 10 to 1 or 20 to 1 or 60 to 1 is really considered limiting. The idea behind limiting is that very little, if anything, is allowed above the threshold. So with a 2 to 1 or 4 to 1 compression, we just get a slight sort of smoothing of the signal. Whereas if we compress much higher in terms of ratio, we create what's called a brick wall limiter, where nothing is allowed to pass the threshold. The third component of any compressor is the attack and release. This can be a bit confusing, particularly if you read about compression in a digital audio textbook. So instead, let's learn about the practical application of attack and release. Attack time is how long it takes the compressor to kick in and start working after the signal has crossed the threshold. If the attack time is 0, or very close to 0, sometimes 0.01 milliseconds or 0.1 milliseconds, the compressor kicks in almost immediately. If I set my attack time to 100 milliseconds, 100 milliseconds means from when the signal crosses the threshold to when the compressor starts to react to the signal and start pulling it down and compressing it. The release time is when the signal crosses back under the threshold. Then the compressor starts to release and not compress. So if 100 milliseconds is the release time, then after the signal passes back down under the threshold, the compressor will wait 100 milliseconds, then makes its way back to no compression. Thus, if 0 is the attack time, or 0.1 or 10 milliseconds, let's say, it moves very quickly to not compression. So if I have a 50 millisecond release time, I might have a gradual, but fairly quickly motion back to no compression. 100 millisecond release time will go even more gradually back to no compression. And then a 500 millisecond release time will be even more gradual. So it's the rate at which we stop the compression. So in general, it's a constant push and pull, grab and release of the compressor. And it all depends on where you have your threshold set, how high you have your ratio set, how quickly your attack time sets in, and how quickly your release time lets go. And all of these things in combination determine the sound of the compression and the style of the compression you are trying to use. So you might ask yourself, are you trying to just get a smooth, gentle compression? Or are you really trying to squash and limit your sounds? But these basic 4 settings are the main sonic characteristics of what you're trying to do with your compressor. Now we can cover just a few of the other more esoteric things you'll find in some compressors. For instance, something called the knee. There are 2 types of knees, something called a hard knee and a soft knee. The difference between the 2 types of knee can be explained as follows. As soon as the signal crosses the threshold, a hard knee will immediately take me up to the ratio I want. For example, if my ratio is set to 4 to 1, a hard knee will get to that ratio as fast as it can. A soft knee will gently and smoothly get to the ratio I want. So typically, a hard knee is a more aggressive compression, while a soft knee is a more gentle or smooth compression. Again, all of these factors will affect the sound we are working with and the end result. The sonic difference in all of this will depend on the voice or instrument or the sound we are compressing. and then the combination of hard and soft knee, the ratio, the attack time, the threshold will affect the sound. So really, the only way to know is to get in and experiment and try things out. Listen and see and hear what each thing does and why it does what it does. And then you can slowly develop your own style for how you can use compression. Most compressors will have some kind of meter on it. Usually on a compressor, you'll see something called a gain reduction meter, which will show how much signal is being brought down by the compressor. And of course, the actual amount of reduction is dependent on all those other things we just learned about. The gain reduction meter will show you how much the compressor is working. Some compressors may have a gain makeup knob. This is not on all compressors, but it is basically a volume knob. So it's a way to sort of bring up the volume of the entire compression plugin. So as you're working with a compressor, you might start to work with different settings, and you might notice some distortion, and then you might ask yourself, is this musical, or is this the kind of sound I want to get? There certainly are standards or maybe correct ways of using compression, and you'll find many opinions out on the internet. And you'll find very artistic uses of compression, maybe very experimental uses of compression, and then maybe very conventional or standard ways of using compression. In the end, if you want to use a compressor, or really any effects processor, you can not only use your eyes and look at things like meters and try to do the math in terms of figuring out the ratios that you want and the threshold in terms of dB. You can certainly begin by using your eyes, but in the end, you have to listen. You must use your ears and listen to the differences and find out what you like and how you like to use compression. Now I'd like to show you a few things about compression that go beyond just a theoretical understanding that we just went over. So I'm in Ableton Live right now, and there are lots of different kinds of compressors out there. There's a compressor that comes with Ableton Live, so I've loaded it onto this track. I've got a little audio track here. Here's what that sound file sounds like without any compression. Okay, so I'm going to activate the compressor, and all I have a very quick release and attack. So both are set to the minimum, and I've got a ratio of 4:1 right now. And all I'm going to do is I'm going to play this file, and I'm just going to slowly bring down the threshold. And as I do that, listen to what happens, and also listen and watch what happens here. So this middle meter is the gain reduction meter. Okay, so what you'll start to notice is at the beginning when I play, there'll be nothing because I have the threshold set all the way to the top. And so basically the compressor is not affecting anything. And then as I pull this down, you'll start to see that there will be some gain reduction happening. And notice how quick it happens. So you can see I've got it set to about 0 dB, and there's a tiny little flicker that happens, but there's really no compression happening. Let's continue. So I've got my compression set, the threshold set to about 6 dB, and you can see there's a little bit of a gain reduction that happens. Now you can notice a little bit more that the presence of the softer notes here are coming through a little bit more as this main loud note hit is really starting to get reduced. I'll continue reducing the threshold even more, or really increasing the threshold. And if you notice that on the output, the difference between the loudest note and the softest note is starting to get closer and closer together. At this point, they're almost even. And in fact, we're almost getting a little bit of distortion happening on the initial loudest note. Let's continue. Now we're almost compressing everything, and the softer notes are getting louder, and the loudest note is getting much softer, and it's kind of a little distorted. So this is where we need to pay attention, listen, and trust our ears in terms of what's the sound that we're getting. So probably ideally, if I wanted to kind of put this into a mix and not have this loud note dominate so much, I probably might set it at maybe minus 12 dB or something like that, and that would bring enough emphasis on the softer notes, reduce this really loud first percussive hit, and so it sounds a little bit more balanced in the mix. And then here it is again without compression. So I'll just turn the compressor on and off and you can hear the difference. All right, so that's the basics. Obviously, what you can also do is try the different ratios, see how that works. So maybe bring it down to 2:1, try 10:1, right? So ways you can do this is set all of this, set the ratio, attack and release, adjust threshold, see what you get. Find a threshold maybe that you like, fine tune the ratio. When you find a few maybe different ratios that you like, you might try different attacks or releases and see when you find something that you like. Of course, this might sound great on its own, and then when I get it into a mix, it might change completely and I'll have to change the compression settings. So here's an example of some percussion with some vocals. And what I'm going to do is I'm going to first play it without any compression, and then I'm going to turn on the compressor, and you'll see I've got my compressor set to, the threshold is set to about 13 dB or so. Ratio is set to 2:1. I've got a very quick attack and quick release. So, so as you listen to this, pay attention to first what it sounds like uncompressed, and then compare that to then what it sounds like when it's compressed. So here's the uncompressed version. I'll let it go one time, and then on the repeat, I will add the compressor.
Come on, come on. 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 Come on, come on.
So to my ears, the uncompressed version, the vocals are sort of being a little bit dominated by the percussion instruments. And when we add the compressor, what happens is the percussive sounds come down just a little bit, and the vocal part, the voices sort of come out of the mix a little bit more. So again, this can be a really interesting way to mix a track that already has mixed sounds in it, where I can try to bring out certain aspects of those sounds. Now I'm going to play you some cello music, actually. This is Yo-Yo Ma, playing a section of a Bach cello suite. So this might be similar to the way I might handle a vocal part. And you can kind of see that I've got some really loud sections here and then some really soft. I mean, there's hardly any signal down here. And so I'm going to play it without compression, so you can hear that uncompressed. And then I'm going to turn on this compression. I've got a ratio of 6:1 this time, so it's a slightly higher ratio. A little longer attack, 0.02 milliseconds, and a slightly longer release, 7.52 milliseconds. And then my threshold is set to minus 14.5 decibels. So here it is without compression. I'll let it play one time all the way through, and then on the repeat, I will add the compressor so you can hear the difference. And so pay attention to the relationship of the louder notes to the softer notes in particular, and the quality of the tone in general. All right, so that's quite different actually, particularly if I play it here from this, I'm going to start playing from this really soft section. I'm just going to toggle the compressor on and off a little bit so you can hear what that sounds like. So you can hear that's quite different actually. So again, I might experiment with changing the threshold slightly, maybe trying maybe more gradual release to maybe smooth it out even more a little bit, and just see if I like what that sounds like. All right, and for the last example, I'm just going to play a little vocal. So again, with this, I'm going to be doing a 6:1 ratio. There's a very quick attack, slightly longer release now, 15 milliseconds. So it's a little bit more of a gentler a compression, and my threshold is set to 12 dB. So let's see what this sounds like. Again, I'm going to play it first without any compression and take notice the quality of the sound. And then I'll turn on the compression on the repeat. And again, compare that to what it sounded like uncompressed.
Baila, baila, ajá, esta rumba azul. Baila, baila, ajá, esta rumba azul. Baila, baila, ajá, esta rumba azul. Baila, baila, ajá, esta rumba azul.
So again, to my ears, like azul really comes out of the texture more when it's compressed. When it's not compressed, I kind of lose it a little bit. And I could certainly see in a mix where there were lots of instruments playing that azul would get totally lost in the mix. Where when it's compressed, it really has a little bit more presence. I can really understand the word. It really kind of comes out of the, and I can imagine in a much more complex texture, I could notice that, where uncompressed, it would just get lost. So what's fascinating is to also try different compressors. So the compressor in Ableton is fine. It does a great job. There are third-party compressors that are fantastic. And what's amazing about this is that you could try compression in Ableton and then try exactly the same sound file with exactly the same settings as like the Ableton compressor in, let's say, using the Pro Tools compressor or the Logic compressor, and it would sound completely different. I wish I had a chance to kind of do that now, and I might do that in another video at some point for you so you can hear that. But you can even try that yourself. So, all right. So this is, again, a very, believe it or not, a short discussion on compression. Compression is so complicated, and we haven't even talked about things like side chaining and other things like that, which we'll get to at some point. But this gives you some sense of what we can do with compression. It's a powerful tool. We don't have to use it all the time. You don't have to use it at all if you don't want. And then if you do want to use it, hopefully this video helps you understand a little bit in terms of some of the artistic decisions that you can make.